Φαντάζομαι μιλάω εδώ. Ακούγομαι, ωραία. Okay, I think we're probably all here, so let's get started. Thank you for coming. I'm Dimitris Bougioukos. I'm coming from Netcompany Intrasoft, and in this quick session, we are going to talk about supply chain security and software bill of materials. So I'm going to give you a glimpse into how these two relate, right? And how do we actually use software bill of materials nowadays to secure the supply chain. So before we move into that, some information about Netcompany Intrasoft. We are a leading IT solutions and services company established in 1996, right? So we're a Greek company operating in 12 countries. And as of lately, we are numbering more than 2,800 employees, right, in all these countries of operations. And yeah, we are mainly based in Greece, right, Athens, Patras, and Thessaloniki, where we have our dev centers. Our headquarters are in Luxembourg, and then we also have other offices, as you can see, in Brussels, but then also in Africa, Middle East, and some sales offices in the United States. Starting now with software supply chain security. First of all, I think we need to frame a bit what is the software supply chain, and here we have a very high-level representation of a software supply chain, right? So on the very left, we always have a producer, right? Someone who's actually producing a software. Then we actually have the source, right? This is what the producer directly authors, right, and puts that into a build process, right, to produce artifacts that a consumer can actually get and use. And by those artifacts, we typically talk about software packages, right, which nowadays they rely on dependencies, right, so code that someone else has written, but then we incorporate in our software to make it available. And then on the very right, we have the consumers, which are the ones that receive the software packages for usage. Now, if we take a moment and think, right, so this very simplified version of the supply chain model, right, it becomes a lot more complex in the real world, right, because we have a lot of different actors, many different systems that could be used for building software, many different dependencies. And with complexity, we all know that things can go wrong with security, or malicious attackers may lurk to actually take advantage of the software supply chain. And having said that, software supply chain security is all about securing the software that we deliver at the very end of this process, but also the systems, right, that get involved into producing the software itself. And now if we focus specifically on the dependencies part of the supply chain, this is where we start getting into the discussion of having a software bill of materials, right, which is nothing else than a list of the open source third-party components that we use in our software, right? And those dependencies may be direct, meaning something that we have explicitly used in our code, right? Or indirect dependencies, meaning that we have a dependency that pulls with it other dependencies, so on and so forth. So software bill of materials, right, so exists to give us the list of open source and third-party components that we are going to ship with our software, right? And they are an important tool because they can help us in risk assessment, which means that organizations can identify security risks that perhaps exist with the open source libraries, the third-party libraries that they include in their code. They also help us with vulnerability management, right? So we need to be able to prioritize, we need to be able to discern which vulnerabilities affecting those components are important and we should invest to manage, right, to mitigate. They also help us with compliance, right? SBOMs are nowadays something that frameworks like NIST or even on a European level are mandated. So producers, especially producers of software, are required to produce SBOMs. They also help us with compliance in terms of the licenses, right? Whatever license we a component might have, whether we can use it in our software, especially when we use it for commercial purposes. And the very last is that SBOMs bring transparency, right? So it means that as a software passes along, right, from one user to the other, from one consumer to the other, or even producers that are in between us, if we are, let's say, the first in line, then everyone knows exactly what components are included in there, and from there they can do their own risk management, their own vulnerability management, and so on. We are talking about SBOMs, and naturally one would think, okay, so what should go into an SBOM, right? So what should be the contents and what requirements do we have for SBOMs? I'm using this example from the National Telecommunication Service in the United States, who acted upon the executive order of the President of the United States to enhance the cybersecurity of the nation, right? And they put out this specification that describes what are the minimum elements for a software bill of material. And in that, let's say, specification, in that document, they're actually talking about three things. So they name specific data fields that an SBOM should have, right? So the essential information that, at the very least, an SBOM should communicate to its consumers, right? And then you would think about, naming who is the producer of the software, right? What is the version of the particular component, so on and so forth. And then the second element that is described and actually mandated in there is automation support. So software bill of materials should be able to scale across many systems, right? And then should be also made machine readable, right? So as to, again, scale the whole usage and consumption. And then the third element that is described in the specification is around the practices and processes for software bill of materials. We can think that once we have the piece of data that an SBOM conveys, right, communicates, then that in itself doesn't mean a lot if we cannot operationalize it, meaning that if we cannot take it, put it into our secure software development lifecycle and action something out of it. So practices and processes in the specification document, they're talking about how often we should be producing a software bill of materials, how should we use it, how we can exchange it securely, etc., etc. The automation support, right, and thinking that we should have something that easily scales and also that is machine readable, it makes us think that there must be some expected data format, right, that we have software bill of materials produced against, and otherwise then it would be, of course, difficult to achieve the automation. So on that topic, right, we have two data formats, two standards that are prevalent, they're most commonly used out there, and basically help us into constructing software bill of materials. The first one is the Software Package Data Exchange, which is an open standard that is sponsored by the Linux Foundation. It is the oldest one, right? It started in 2010 and actually gets named as the standard that can fulfill the requirements of the respective ISO, right? That talks about how we can create, how we can construct software bill of materials. And the second one that is a bit newer is Cyclone DX. The whole project started in 2017. It's actually a NOAA's project for those that don't know it, and it was actually built from the start thinking about reducing cyber risk or actually managing cyber risk, and it was built with the intention to be used in the dependency track tool, which is a software composition analysis tool for those that are more familiar. In all cases, both standards are out there for some time now. SPDX is the one that is more widely adopted, and we can imagine why, right? So it's there since 2010. But if we think about their scope, SPDX was originally developed for monitoring license compliance, right? So what kind of third-party components are we shipping, right? And whether we are entitled at the end of the day to ship them, right? For commercial purposes of our software. Whereas Cyclone DX is mostly focused on security, and also Cyclone DX is more customizable if you compare it to SPDX, which is more formal, more rigid as to what fields, what should be described in a software bill of material. In all cases, both are utilized in terms of security nowadays a lot, and there are a lot of tools that can support generation of bill of materials as per those two standards. If we focus a bit on the SBOM generation, right? So the SBOM generation is typically happening at the build stage of a CI, of a continuous integration pipeline, right? The benefits of having that happening in the build stage is basically the place where we can, let's say in one shot, actually identify all our dependencies, right? And produce the SBOM. If we try to do that in other stages, then we would probably miss some of those, right? So if we think that we have an artifact, let's say we have a Docker image, and then we try to produce an SBOM out of it, then we will probably be successful, but then we wouldn't be getting the full visibility as we can do the moment that we actually build our software. In any case, the creation of SBOMs, right, is basically leveraging tools that are integrating with our CI servers, our package managers, and those tools actually make their own artifact, right? It could be a JSON, it could be an XML that at the end of the process, right? It could be also an output that we can share with the client or whoever receives our software. I have included here some well-known tools, right, that we can use for SBOM creation. There are many more out there. I mean, perhaps some of you know more, and they don't see those in here. It's indicative. Cyclone DX Maven plugin, it's quite popular, right? Especially in the context of using dependency track, which is the tool that is sponsored, or at least is developed under the auspices of the OWASP. And then we also have Sneak, which is a paid tool, right? So this is a private company that markets the tool. Microsoft has open sourced an SBOM tool that actually gets its output into the SPDX format. And then we have Sift and Fossa, but okay, these are indicative, right? So there are many, and you can find even more tools that actually do not fall under the build stage, right? So you wouldn't use them in the build stage to get an SBOM created, but you would actually either do that earlier, right? Even during development, or when you actually have the deployable artifact at hand. And concluding this short talk, I want to highlight where, let's say, the sort of state-of-the-art currently is at increasing risk transparency with SBOMs. So basically, what we say here is that we have a software, we get a bill of materials, and then out of the bill of materials, we can identify that we have 100 vulnerabilities that affect the third-party components that we have included in there. That's nice, right, to know, but not all of these 100 vulnerabilities are actual risks for our software product, right? So some of these might be false positives and basically might mean nothing for our software. So this is where VEX and VDR, Vulnerability Exploitability Exchange, and Vulnerability Disclosure Report artifacts are coming in. And those two are basically coming in to complement the SBOM information and provide, in the case of VEX, a negative attestation of vulnerabilities that are not affecting our software, right? So we have the SBOM, we have the dependencies, we have the vulnerabilities that affect those dependencies, and then VEX is a statement that this set or subset of vulnerabilities are not affecting my software. And this is what finally gets shipped to the client, and then the client knows that, okay, I received your product, and then based on your declaration, right? So there are only 10 vulnerabilities that actually should interest me, and maybe take mitigating measures in production, right, to avoid any damage. VDR is also similar. VDR takes things a step further, actually conveying also the impact of the vulnerabilities that are affecting the software. So here, whereas VEX says that, okay, these vulnerabilities do not affect my software, VDR says that these vulnerabilities are the ones that are true positives, and they have this kind of impact should they be triggered against the software in production. And yeah, so basically this is how risk transparency via SBOMs gets increased, or currently companies and practitioners try to get more out of it. The point here is that we want efficiencies, right? So if we have 100 vulnerabilities and 90% of those mean nothing for our software, then security teams, development teams would actually be wasting time to mitigate those, whereas only 10 of those are the ones that require our immediate attention. And not to be mistaken, right? So most of these vulnerabilities, even if they don't affect our product, right, they actually point to that we have to do some dependency management, which is different. So yeah, eventually we will have to come back and manage those dependencies anyway. And yeah, that concludes my short talk on SBOMs. Thank you very much. Just to say that we also have some open positions in Netcom and Trasoft. Feel free to explore and apply. Thank you.